Alright guys, so what we're going to do in this video is we're going to look at some of the different ingredients, some of the components of motion that are going to be really important for the course. So there's just a few here. First I'm going to give them to you individually, and then I'm going to show you kind of how they all work together to describe all types of motion. So first thing I have here is displacement. So this is a little bit weird because it is very similar to the idea of distance, but distance and displacement are not exactly the same thing. Okay, but they are similar concepts, and that's going to be the theme with a lot of these here, is they're going to be very similar to what you already know and have an intuition of, but with some minor difference, right? So if I talk about distance, what I'm describing is how far do I travel, right? So let's say, I start at some point, I walk all the way over to some other point, then, I've traveled some distance. Now, distance, let's say if I'm moving in a track, so let's say I'm running around some track, and then I come back to my original point. When I make this round here, if I'm just counting distance, I'm essentially, counting some measure of, let's say, my steps or something like that. That will keep increasing, right? So I can keep going around this track more and more and more. And so let's say one lap is like a quarter mile. I do it again. So now my distance is, half a mile, 3/4 of a mile, and I'll keep doing this over and over, right? But displacement is not like this. Displacement, the big difference here is that the only thing I'm considering is where do I start, right? So let's say I start at this point here. And where do I end? Okay, so let's say I end right here on this part of the track. So I'll mark this here as my endpoint. And if I do this, my displacement is not this whole track right here. Okay, when I talk about displacement, what this actually is all it is I take my starting point and my ending point, and I want to find how far apart are those 2 points. I don't care what happened in between, right? So in this case, it would be from my starting point to my ending point. How long is this line right here? This is my displacement, and it's marked with a variable delta x. So this displacement right here, I can mark it as delta x. This is the way you're going to see this variable right here. Okay, so the math way that we use to describe this distance between where I started and where I ended, okay, is just my final position minus my initial position. Super simple. So an example here, I could tell you I start at some point x equals 0, I end at some point x equals 10, and if I do this, my end is 10, my start is 0, I'll do 10 minus 0, that'll give me displacement here. Okay. One thing here that you're going to see a lot is this little vector symbol, this little arrow that I've put on top of my variable. What this means, and we'll get into this more in the vector lesson, is that this has direction. This can be positive or negative. This can be backward or forward. There's a difference. For distance, there's no difference, right? It's just how far. So there's no how far forward or how far backward. Those two things are the same distance, right? A foot is a foot, it doesn't matter. But displacement has direction always attached to it, okay? Next thing here we're going to go through is time. Super simple. Before we go on, I have here this unit. This is my standard unit that we're always going to see. The standard unit that we use for displacement is going to be meters. So not feet or not miles, anything like that. When we talk about displacement, we're going to be using meters. So if you see a value that has meters on it, you're probably looking at displacement, some sort of displacement, or a value like this. So this is a length variable, a length unit. So here, next we have time. So for time, of course, this is just time normal. Time is going to be a pretty standard thing that's going to connect a lot of ideas for us. one thing that I want to show you guys here is the unit is in seconds. So my standard unit is always going to be seconds. Okay? And then here, the variable that you're going to see used for time is just going to be this lowercase t. Okay? And you might see this as how much time has gone by. Okay? So if I say something like change in time or how much time has elapsed, anything like that, pretty much how much time has gone by in the time that it took a certain thing to occur. And if you do this, what I'm going to do is I'm going to usually show this as delta t. This just means, this little thing here means change. This change in time, same thing here. My change in position, okay, that's my displacement. My change in time, that's how much time has gone by. But this is the variable you're looking at here, just this lowercase t. Okay, next thing here is velocity. Again, velocity and speed are very similar, but they are not the same. Okay? My standard unit here for velocity is meters per second. You'll see this right here. So you can kind of tell already this is a speed. This is, we're used to things like miles per hour. Okay? And so it's very easy. It's just telling us when we talk about velocity, okay, this is my variable, this v with a little vector symbol on it. And this is just going to be my displacement. Whatever displacement I have completed, right? And then how long did it take me to do that? So this is the same thing. If I go back to this track example right here, the only thing velocity tells me is how long did it take me to get from this point to this point. Again, I don't care what happened in between. If you take time into account, it will give you an average velocity, right? So it doesn't matter if I went straight from here to here and it took me 10 seconds, or if I came all the way around and it took me 10 seconds. Yes, I moved faster, but some of that velocity is going to cancel out because some of it is positive, some of it is negative, right? So it ends up being actually very, very simple in that the way we use it is just how far did I go, right? What is my displacement? Divided by how much time did it take. So that's why this unit here is just combining my two standard units, my displacement over time, meters over seconds. Okay, so when we do this here, the way you're going to see this, I'm going to go and change this here to green, is going to be my displacement divided by time. Okay, so if I wanted to expand this with this formula up here, then this would be my final position minus my initial position over time. Okay. Now, very similarly, I have acceleration. When I talk about acceleration, I have a lowercase a with this little vector symbol on it, right? So remember, these vector symbols, we're going to go into this more in the next lesson. But the important thing here is that it can be positive or it can be negative. So when we normally talk about acceleration, you might hear slowing down as deceleration. Here we're only going to use the word acceleration. It doesn't always mean speeding up, okay? And we'll talk about that more when we get into vectors and motion, but you can have a positive acceleration or you can have a negative acceleration, right? So in some cases, it could speed you up. In some cases, it can slow you down. It depends on which way you're moving, right? So in this case here, acceleration, we kind of have an intuition of this also, right? This is my change in velocity, okay? This is how much do I speed up or slow down, right? That's kind of describing acceleration, but there's one piece missing here. Let's say I speed up from 0 meters per second to 100 meters per second, but it takes me a day, right? I'm speeding up, but super, super gradually, right? So in this case, my acceleration is actually really small. I'll end up going very fast at the end, right? But my acceleration is very, very small. So in here, the thing that we're missing is also time, okay? We have this idea of time that we're going to bring in. How much did my velocity change and how long did it take, right? It's this 0 to 60 in whatever seconds. That's this kind of measure of acceleration. So here, for change in velocity, remember I'm going to use the same rule that I did here for displacement and for change in time. I'm going to say my change. Oops, let me go ahead and go back here. This is my change in velocity over time. Or my final velocity minus my initial velocity over time. You'll see this pattern here in that this little delta, this change in something, can pretty much always be summarized. The average change of something can always be the end minus the start, right? The final minus the original, or the final minus the initial. Always be something like this. Now, for the units for this one, I want you guys to remember this, is that it's always, acceleration is always describing how many meters per second does something change every second. Okay, so it sounds a little weird, so we'll say like, it's the change, or I'm going to go ahead and write this out. So I'll have the change in meters per second, okay, every second. Okay, so I can write this. Let me go ahead and move this just a little bit. I can go ahead and write this as meters per second per second. Okay, this is the same thing as meters per second, right? This would be meters per second per second. And lastly, if I just put these all together, this is meters per second squared. Okay, so this one's going to be a little tricky. You guys are going to have to play with this for a little while, this idea, right? I just wanted you to just kind of play with the idea of how many meters per second is my velocity changing every second, or meters per second squared. And the last thing here I'm going to focus on for this video is going to be mass super quickly. We're not going to get into this until we start talking about forces. The thing that I want you guys to know is the mass is kind of how much matter is something, right? So mass is not exactly weight, okay? Your mass doesn't change whether you're on Earth or you're in space, whatever. You're the same amount of stuff always. But your weight can change if there's gravity or no gravity, right? So mass here is something we're going to be using a lot later on. The important thing here that I wanted to point out is that my mass, my standard unit, is in kilograms, okay? So just kind of to point that out for you guys right now. So in the next video, we're going to talk about kinematic formulas. So we'll get started on that in just a bit.